It is, 57 slides, all in fine point. I'm going to read it very slowly now. So this is Hacking Laboratory Information Medical Systems for Fun and Profit. This happened during the height of the pandemic. We were working with a company that did COVID testing. We were specifically providing Mechanical Turk services for bringing in their forms that were literally scanned copies of medical documents and typing it into their systems for them. Their big problem was that in the medical industry they have accessioning, where you go to your laboratory system and you basically give the final result from the laboratory and you say, here's what's actually happened. And they were getting further and further behind on this. So literally when I started, it was coming up on Christmas and they were still trying to tell people that had done COVID tests before Thanksgiving whether or not they had COVID. Unfortunately, it was a little bit late to determine whether or not visiting grandma was a good idea for Thanksgiving when we were nearing Christmas. So that brought us into this problem. They had come up with their solution to this, which was that if we could just automate the process, we would be able to move forward and maybe they'd get some stuff caught up. So they sent out their hey, just install this software, which they noted was not a Windows program, by which they meant it really was unsigned software, not that it wasn't a Windows program. And drop in all these passwords and it would just magically work, at which point they wanted us to use Power Automate because we had a bunch of extra machines laying around, so we could just set up a farm to click through on these things. You'll note that a couple of these things look very familiar. SSH ports, that it has a key file, and that'll come into play later. So popped into the software, which uses a static password for setup. The idea being simply that a end user won't know that password, so they can't change their setup. But if anybody wanted to say, well, there's strings in the executable, it would have been there anyway. But we can see it's got an SSH server that's connected to port 22. Once everything's thrown in, it has its key files. So we knew something of what it was doing under the hood. So once we were in, it had this lovely dumb terminal interface telling us even more of what it was doing under the hood. We got started on this only to find out that it had rate limiting for user inputs, so that you couldn't type too fast because they thought all this would be done like one at a time by a guy in a laboratory looking up the results, because they did other sorts of testing, blood tests, etc. And you would look them up, you type it in, you move to each next screen, and if they slowed you down, you wouldn't make mistakes, which obviously didn't work too well as this grew. The real problem was they also had a limited number of logins. The Power Automate was slow enough that by the time they actually figured out how many of these logins they could use, they couldn't even actually get caught up, let alone come deal with the new ones coming in. So they needed some other way to do this, and of course they contacted the manufacturer of the software because it had to interface with all the medical systems to hit up doctors and do insurance and get all that parts, and they said that they could probably get a fix for them in about 6 months, as software development lifecycle always is. So I immediately tried the very simple, let's just see if we can SSH into it, but we couldn't. So that
port 23, right?
Yeah, it was port 23 for part of it and 22 for the SSH part. So it unfortunately did not work at a roadblock, but it worked when we used their cruddy old Windows software. So time to do a little man in the middle and grab Fiddler Classic. For anybody that hasn't played with it on Windows, this lets you very quickly set up a HTTPS man in the middle and look at all the traffic and decode it. So the first fun part is you actually go in and tell it to decrypt all your HTTPS traffic. And then it starts, really warning you with the nice pop-up of scary text ahead, do not trust certificates, and several steps of, are you sure you wanted to trust adding this as a root certificate? Are you sure you're sure? But if you click through all of those, assuming you trust the software, you ultimately end up with 2 brand new root certificates that tell you not to trust them. Which is actually probably good, because if you're going to install root certificates that aren't real root certificates, at least maybe it's a clue for people. And we can see I now have 63 root certificates on my computer. As soon as you go in and open their software, we can see it was making an HTTPS connection. In fact, first it makes an HTTPS connection and gets a 401 and fails. And then it does a second one, gets a 200, and the endpoint is punch, which would indicate to me that that's hole punching an opening for us. So if we go in and we actually look at the connection, it's using basic auth. And furthermore, if you look at the auth, it auto decodes it to this lovely string that never changes any time any software wants to connect into this laboratory's servers. And while I could have redacted the password, if they're going to leave their password that simple for everything, that's their fault.
Bananas?
Yes, with some numbers in the middle.
Okay, cool.
Because no one could possibly guess that, and why would we make it unique per user?
Well, it's plural, so it's impossible to guess. If it was banana, it'd be a risk.
Then it'd be a real risk.
So it's salted with the S.
Yeah.
So after trying that, an SSH to the same port, oh look, it's talking to us. So that was their vast security. There was no port knocking. There was, so long as you used a basic auth connect to that HTTPS endpoint, now you can SSH in. Lucky you. So, of course, the first thing I did was then immediately removed all the root certificates because if you're going to do that, you don't want to leave those around for the next chunk of software that decides that, hey, we'll catch a good developer by, they're never going to install these. And of course, go into your certificates and make sure they're actually gone afterwards, because not doing that and blindly trusting software to remove it is probably not a good idea. So, cool, now it is time to test this from a command line. Let's start getting out of the ugly Windows world and into our nice, happy command line. Throw it together as a curl, put in the basic auth, auto-close the connection, and it actually helpfully returns the text that access through the firewall is temporarily permitted for you. So, that HTTPS page really did have some content. And then I turned around and turned it into a shell script. This shell script was so that every single time I tried to connect, I didn't have to, knock and, maybe have them notice that, hundreds of thousands of records had to, open the port. Literally all this does is touches a file, then checks if the file is, too old. If so, it touches it again. So this just is a very quick skip everything if they're letting us in. And check for an expiration. If not, do it again. So cool. Once we knock, we can actually SSH in. This was great, except it dropped us to this nice prompt that was just a $sign. It was not the CLI we were expecting. Looking through, we could see all the user accounts for the users that were set up, and that they had a specific shell that they were supposed to open into that was really a shell script, but trying to run it under this one, got into pathing hell and didn't work. So, let's just go a little old school and telnet right back into the host now that we're in, because it accepts its own connections just fine. And hey, now it's actually dropping us into a prompt. And as soon as we put in our user and password, we get this lovely, screen that exactly matches the original GUI. Literally everything they've written in Windows was just a wrapper over the terminal. Unfortunately, once you dig into it, they're doing really ugly things with VT100 codes. You're not actually seeing the terminal as the terminal, which makes it a little bit harder here. We're kind of small to see here, but circled is the username and password prompt. And if you look at it afterwards, of VT100 codes, to move the cursor around the screen, the developers clearly just kept adding things on at different times, so you can't just wait until it gets to a certain point, because It'll go, and then it'll come up here and add a little to the screen, then it goes back down, and adds a little over here, as they added features over time. The upside is, hey, there are really old things. In this case, expect. Expect is, you got it, the ancient stuff. In fact, expect is really just a extension to TCL and was written in 1990. So, it is not very modern at all, and in fact, its latest update's 2018. And TCL itself was actually written in '88, so I was like 10 years old when this stuff came out. So, yeah, old problems require even older solutions. Wow. So now I know how to, watch for stuff in there, and it's time to just bang something out. Unfortunately, at this point, I have one hammer. Everything, is a nail. So I threw together a really quick database that pulls the accession number. That's the number they assign to each lab desk, and 2 date fields. Super lazy in that, if you hit up the server, it orders by new ID, so it randomly picks one record, and then it sets the checkout date to the current timestamp, so that we're not going to check it out twice. And when I'm done doing stuff with it, I have a check-in that adds a check-in time, so we know it's finished. In this case, they had a small number of positive tests and a huge swath of negative tests. So the positive tests could all be done by a human and make sure they jump through all the menus. The negative tests, however, just needed to be cranked through over and over. They did a lot of testing for like Hollywood Studios, where they would do combined tests, like take everybody on the studio, mix all the DNA together, enhance it, and see if that one sample had anything, and they're like, okay, that has nothing, so we can mark out all of these. Yeah. So, but then they were literally testing, 500 people every day. So they just had so many of these to do. So now we're, into actually doing this. Here's our little expect script. It does its knock to get in. It drops in a user and a password, and that is all being done in a for loop where we're just looping through over and over. Unfortunately, every once in a while, the thing would bring up other things, like it would do a pop-up that said too many people were using it at once, and you couldn't reliably expect these. So we just did it in a loop. Said, hey, try and loop through 100 of these. If you stall out, oh well. So we have a script that will loop through. Inside that is some really ugly spaghetti code that's just like, hey, on the first screen you press these 2 keys, and then fortunately their GUI overlay would like highlight the hotkeys, so it was manually just go through and like, okay, but where you'd think you could just expect the last part of the prompt, because it was out of order, you sometimes just had to, like, when the cursor goes to this one using this VT100 code, now we're ready to type in the next thing. All of this worked great, except for the fact that it was still too slow. So it needed some multi-threading, and this is like the worst way you can do multi-threading, but it's also super simple. So sequence just lists all your numbers, in this case from 1 to 400, pass it into XArgs. Does parallel processes, so we can run more than one of these, in this case 10 at a time. Basically we'd speed it up until it slowed down so much for the actual human users that they were unable to use it, and we're like, okay, we have found the max. And then each of these did a different thing, with slightly different spaghetti code to either just a session or do a full session, or do negative tests, or do positive tests, and very quickly we got them all caught up on these, and thus they were able to run through. The big thing for me was making sure that people actually knew their health status on this, even though the laboratory company never managed to get any direct software updates to put this in. This let us quickly go through, get everything caught up. They offered me a nice fruit basket for all of my work, which they never sent. Nice. Which brings us to the final thing, profit. Anyway, they now have 2 corporate jets for all the billing they got out of this, and clearly hacking is not the profitable way to go through this. there you go, a quick and dirty romp through how to hack laboratory information systems.
Okay.
Did your expect script tell that in after an SSH in?
Yes, so it SSHs, and then it waits for the prompt, and then it telnets, and then user and password.
Gross.
Yes, so an incredibly ugly pile of code. The manufacturers of laboratory information system, never figured out how they got caught up so fast. But they were able to confirm that they had put in artificial slowdowns in their GUI to prevent human error.
Yeah.
So I missed the impetus. Why were we doing this?
So, ultimately, middle of the pandemic, and I was doing it because I figured, hey, if I can at least get people their results, they can make, smart decisions based on this. So for me, it was, help humanity. For them, it was bill insurance.
Okay.
Ultimately, the laboratory behind this, the reason they started doing so many tests is if you were on like Medicare or Medicaid, the government would pay you $75 per test. So if you just went down to like the local homeless shelter and said, who wants a free test today? That quickly adds up. Private insurance sometimes would pay more. So if you had an entire Hollywood studio paying you for 100 tests a day and they could bill it out to insurance at $600 a pop, but they were so far behind that they couldn't help the real people that needed it. So.
How did you get involved with this?
So ultimately, I worked for a call center, and we were approached to do the Mechanical Turk stuff to begin with. In that, they originally got a form with a person's, like a picture of your health insurance and your driver's license and so forth, and they just needed them all typed in and verified. And so we're like, okay, we can queue this up where it's show a PDF, have one agent type it in, next PDF. Because internally they couldn't hire enough people to go through these, and we're like, well, it's just kind of like call center stuff. You just queue one up, you do the next one. You queue one up, you do the next one. So very much like the ugly PHP code earlier, except PDF files to a human, and then had to click how it was done each time, or did they correctly enter it? This one can't be read, et cetera, et cetera. And then they knew we had a bunch of computers sitting around because, again, middle of the pandemic, so we had empty call center computers too. And they literally were like, hey, could you run our Power Automate script on your computers? Could we buy computer time from you? And so that was how we originally hit the problem, and found that was never going to be a solution. So once we had permission to see what we could do, we went to Hacking Path.
Wow.
I'm surprised they used SSH.
Yeah. I wacky SSH, HTTPS port knocks, and really old software all the way down.
Yeah. We have CentOS 7 with
Yeah.
6 was, geez.
No, and the system was even weirder in that the lab corporation had their public servers, which then actually VPN back into an on-site server that was an old iron CentOS that they had access to, and so ultimately we set up just a Linux VM, walked them through how to load your files into SQL here, go in and run this script until they're done. When they're done, you're going to have some that don't ever have a check-in because something wacky happened, because there were other menus like, hey, this person is in, but they match somebody else's name, and you need to add a phone number. And so we're just those go back to humans. So the ones that never get checked back in, send it back to a human. But it was such a small percentage then that we were able to, shrink it down, get them caught up, and start getting people results in time.
Wow. So what was up with the rate limit? Where it was
So literally, the manufacturer thought that when a person was using their Windows GUI, that the actual human lab tech typing these in, if they typed too fast or they clicked next too many times, that they were likely to make errors. So it would have the when you clicked OK, it paused on that screen for 20 seconds.
Oh my gosh.
So you could see what you put in before it went to the next screen. And so ultimately we started by saying, hey, you really should just go to the manufacturer and like get an API because you want to push data in and out of the system. That's what APIs are for. But because they had so many other testing labs in the middle of this, they're like, oh yeah, we're so far out. We can't, you'll just have to figure it out. Really what the manufacturer wanted was to have so many different labs, each, with a different set, but this one got big in that they, figured out how to expand fast, and so they were one of the first big labs to do testing.
Gotcha. Wow. Wow.
In fact, weirdly, I wandered in first to consult for them because before we were even entering the data, they're like, we just can't figure out how to keep up with these. So I drove down to Oklahoma in the middle of this pandemic, went into this lab, and was like, well, I see all these like inefficiencies in your process. This is not my bread and butter. I don't know, but like, you literally have one person take out one sample and one piece of paper and go to a computer and type in all the person's info, and then print a label on this, and then print a label for the piece of paper, and then file the paper, and then go take this one to the, the test tube to the lab. You could probably like streamline that. So one of our first things before we even started entering data for them was, if you printed a GUID and stuck it on the form and a GUID on the test tube, you could marry these up later. So one guy could just sit there processing forms and the test tubes could move along, and then once your testing's done, you could link them back.
Mm.
But how would you make sure that, they're not the same? What if two different people printed them? And it took them forever to understand that, they did not have to be sequential.
Nice.
Randomness.
Yeah.
So where did this software come from? This wrapper for a command line, where did
From
that
the
idea
same
come
company
from?
that made the command line software to begin with. So this, they provide a whole bunch of back-end laboratory software to medical testing. And ultimately, it's meant to do many, many more things than this. You want to find out if your girlfriend has chlamydia. You want to find out if, you've got blood cancer. You want to, all those would go to a lab, and they would have a different flow for each one of those things built into the software. So probably every one of you has had some test done when they've done like a blood draw or something. And this lab, prior to COVID, that was all they did. The local doctor's office would send out labs. They would go through, and your human knows how to read this. And, the testing computer over here says that your blood sugar is this number, and and they would just go through the fields and type in each one, and then that ultimately does exports back to insurance carriers and all that. So when you see it in your insurance carrier portal, it comes through that. So that's what it's meant to do under the hood. It's just not meant to cope with large numbers of tests and that need to be done in a timely manner.
So all of these different providers are expected to interface with their database in that.
They are expected to
software.
use the Windows thing that overlays it, and if you're only entering 100 of these a day, it's no biggie to wait 20 seconds here, 20 seconds there, and you probably have 5 people doing it, so each one of them's really only entering 20, so it's not a biggie. Once you start getting up to thousands and thousands of tests, then it just couldn't cope.
Crazy.
Yeah. So it was fun because it was a white hat hacking adventure. To be able to go in and do traditional hacking. Obviously, it looks better when you're done. And you're just like, here's how we solved everything. You have a lot of stops along the way when you're really doing it. Like, why can't I get to this? What do we do under this? Can we inspect the? Originally it was, can I inspect the traffic that is going through? Because maybe I could just pick out the traffic and directly inject mine, until I realized that the traffic was really just opening an SSH terminal and, literally doing the same sort of expect scripts, except, they wrote the software on both ends, so they just wrote front end and back end. Oh, you're on this screen, display this. So that was the start of the rabbit hole.
Gotcha. Wow.
I'd be interested to know if their program did host key checking in SSH, because you could have, if it didn't, you would man in the middle of the SSH connection.
To log in, you had to use a host key, which they conveniently provided the same key to everyone who uses the software. Came in a zip file, at the same time. So the setup password was the same for everyone. The port knocking password was the same for everyone. The host key was the same for everyone. After that, you got to basically the telnet login inside it. That one, was semi-unique per user, as in usernames were letter, user number, and the same password for everyone. And then you got to the actual software, like after the login, where it was the same user and password for everyone as well.
Oh man.
Yeah, so I mean,
That seems problematic.
it's almost like, it's terrifying to know that all of our HIPAA info goes through systems like this every day.
Yeah, I was gonna say, that's probably not very HIPAA compliant.
FAA does it
Yeah.
But it's encrypted.
all the time.
Yes.
It meets the.
It's encrypted.
It meets the requirements, but
Well, it is encrypted.
Yeah.
It's SSH, so you're good, right?
Well, HIPAA's very spirit oriented. Yeah,
Yeah.
I tried to protect it. There's a password.
Yeah, we protected it somewhere. It was encrypted in transit.
Yeah.
And to be fair-ish, you had to know a handful of things, but an internal actor could have done anything. As evidenced by literally me being the internal actor here. And while I only used it to do the things that I should have for the business, obviously you could go through the screens, you could harvest out people's insurance information, their personal PII, because it was all there in other screens. That was just not the purpose of this. That's the white hat. But clearly black hat would have been more profitable for me.
Wow.
Like I say, they now have 2 private jets, so it was very profitable for them.
Yeah. Wow.
So no